Good day, students. In this clip, we're going to be going over an example on how to solve rational inequalities. And afterwards, I'll give you an example to try out, okay? All right, so for question one, we're going to solve the rational inequality x plus 1 over, over x minus 2 is less than x over x plus 3, okay? All right, so this procedure for solving this is somewhat similar to solving quadratic inequalities. What we want to do here is we need to find all the boundary points, and then we're going to test all the intervals around these boundary points to see which one is good and which one is bad. Basically, which one satisfies this inequality and which do not. And the intervals that satisfy this inequality will basically be our solution intervals, okay? So what we're going to do first is find all boundary points, okay, all boundary points for the solutions and the regions that are not our solutions, okay, so find all boundary points. So our boundary points are basically places where the inequality is undefined and the solutions, okay, so one is where inequality is undefined. Those are boundary points. And second set of boundary points are the solutions to the equation form. All right, so what we'll do is we'll basically express this as an equation and solve for the solutions that will give us the other set of boundary points, okay? So let's find the first one first. Where what values of x is this inequality undefined? Well, all you simply do is you set the denominator to 0. Okay, so for part 1, where the inequality is undefined, you set denominator to 0. Okay? Alright, so we have two denominators here, so we have to set both of them to 0. Alright, so the first one, x minus 2 equals 0. So you add 2 to both sides, and they have x equals 2. This will be our first boundary point. The next one, x plus 3 equals 0. You subtract 3 from both sides. X equals 3 will be, x equals negative 3, sorry, will be our second boundary point, okay? All right, now we're going to do, get this next set of boundary points by actually finding solutions to equation form, okay? Solutions to the equation form. All right, what do I mean by equation form? All you simply do is convert your inequality into an equation and solve it as though you were solving a rational equation problem, right? So we're going to have x plus 1 over x minus 2. Instead of less than, we're going to have equals x over x plus 3. Okay, so any value of x that satisfies this equation will also be a boundary point. All right, so how do we solve this rational inequality, this rational equation? Cross multiply first, x plus 1 times x plus 3 equals x times x minus 2. Okay? And then we can distribute this out. We're going to have x squared plus 3x plus x plus 3. And on the right side, we'll have x squared minus 2x. Okay? All right. Let's see. Let's simplify this further. It looks like we're having an inequality, a quadratic here. So we have x squared plus 4x plus 3 equals x squared minus 2x. All right, so what we can do, let's go ahead and subtract x squared from both sides and add 2x to both sides. Get all the variables on one side. All right, so that yields, this cancels out. This becomes 6x plus 3 equals 0. All right, so subtract 3 from both sides. We have 6x equals negative 3. And then we'll divide both sides by 6. And then we'll have x equals negative 3 over 6, which reduces to negative 1/2. Okay? All right, so now we have all our boundary points. Let's write them down. Boundary points boundary points in ascending order are -3, -1/2, and +2. The first and the last are the ones we got from finding the points where the inequality was undefined. Okay, so what we're going to do is we're going to create a number line, label our intervals, and then we're going to test each interval to see which one is a solution region for our inequality. Okay, so let's draw ourselves a nice little number line. This is 0, let's put 0 right here, 0, 1, 2, 3. So this right here is -3. This is our first point. I put an open circle here. And then -1/2 is going to be somewhere here. First x boundary point. And then this is -1. And then 2, 1, 2. This would be our third boundary point. Okay, let me make sure they're all lined up properly. So we have one at 3, one at -1/2, and one at 2. Okay, so let's put a circle here, and a circle here. Since we have 3 boundary points, that gives us a total of 4 intervals. Okay, so we have interval number 1, interval number 2, from here to here, interval 3 between these 2 points, and then this is interval 4. Okay, all right, so what we're going to do is we're going to pick test values in each interval that we're going to plug into our inequality to see if the interval is good or bad. So in interval 1, we can pick any number that's less than -3. We can pick x equals -4 to test here. And then for this interval between -3 and then -1/2, it's -1/2 over here, we can pick, how about we just pick x equals -1, and then interval 3 between -1/2 and 2, x equals 0 is pretty easy, and then any number bigger than 2 will satisfy interval 4. We can pick x equals 3. Alright, okay, now we're going to go ahead and do the test. What we're doing is we're putting this test candidate for each interval into the original inequality, x plus 1 over x minus 2 is less than x over x plus 3. Okay, now the first one, interval 1, we're testing x equals -4. So let's plug it in here. The question is -4 plus 1 over -4 minus 2, is it less than -4 over -4 plus 3? Is it? Let's simplify that further. -4 plus 1 is -3. -4 minus 2 is -6. Is this less than -4 over -4 plus 3 is -1? Is that true or false? -3 over -6 is simply +1/2. Is +1/2 less than +4? Absolutely. So this is a good interval. That means interval 1 is good. Okay. All right. Now let's shift our attention to interval 2. Interval 2, we're testing x equals -1. Let's plug it in here. So the question is -1 plus 2 over -1 minus 2, is it less than -1 over -1 plus 3? That's the question. So let's see, it's supposed to be -1 plus 1 over here. Okay, a slight mistake. -1 plus 1. Alright, simplify it. Here it's going to be, you're going to have 0 over -3. 0 over -3 less than -1 over 2. Simplify it further. Is 0 less than -1/2? Absolutely not, so interval 2 is bad. Alright, let's shift our attention to interval 3. Interval 3, we're testing x equals 0. That should be easy. Question is 0 plus 1? Is 0 plus 1 over 0 minus 2? Is it less than 0 over 0 plus 3? Simplify it. Is -1 over 2? Is it less than 0? Absolutely. Okay, so this one is good. So interval 3 is good. All right, last interval we're going to test is interval 4 from positive 2 to infinity, okay? So for interval 4, we have x equals 3. So the question is 3 plus 1 over 3 minus 2, is it less than 3 over 3 plus 3, is it? Simplify that further, is 4 over 1, is it less than 3 over 6? Simplify further, is 4 less than 1 half? Absolutely not, this is false. So interval 4 is bad, okay? So just to help you see which solutions are good, just interval 3 and interval 1, okay? All right, so let's graph the solution intervals of our valid intervals. So we have interval 1 as being good, so from negative 3 all the way to negative infinity is good. And then we also have interval number 3, which is between 0 and 3, so from 0 to 3. Okay, so there goes the solution of our rational inequality. Okay, the other intervals are no good. So how do we express this? Express this using inequalities. So let's write this down using inequality notation. So solution is going to be x is less than negative 3 for the um, interval 1, and then for interval 2, actually interval 3, you're sandwiched between two values, namely negative 1 half and 2. So negative 1 half is less than 2, and 2 is less than, is less than x, is less than x, and then x is less than 2. Okay? That's what happens when you're in between these two intervals, between negative 1 half and 2. Okay? Another point to note is this negative 1 half piece right here. Because we do not have a line, that's why it's open circle. Had it been we had a line under this inequality right here, if we had a line there, then guess what? That 1 half would be a candidate. This would be a closed circle. Okay? We know it's undefined at 2 and negative 3, so those ones can be closed circles. But this one, since there wasn't any line on the inequality, that's why we have an open circle there. Alright, so this basically is a solution to your rational inequality, okay? All right. All right, so how well did you understand this example I just did? All right, so I'm going to challenge you, try this. Try this example. Example 2. So the task is to solve the rational inequality x minus 2 over x plus 4 is less than x over x plus 3. Okay, so what I'd like you to do is solve this rational inequality completely, and in the comment below I want you to post what your answer is or any complications you have, okay? And then I'll make sure I send you a direct response to tell you if your answer is right or wrong. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking up here so you can get updates to other cool videos such as this, and also you get notified when I respond to your posts. Please post a comment either in response to the answer I gave you or to tell me how well you understood this explanation. More clips can be found on untitled.com. Thanks again for watching and have a wonderful day.